Here's a problem that we can use theorems that we've already learned up to this point with some trapezoids. We learned some definitions, and we're going to look at some things that are true about trapezoids, that we can prove about trapezoids, not necessarily theorems, but after we prove something formally, we can use that in future proofs as well, if it follows all the theorems about geometry and all that. We can use that proof that we've done previously in successing kind of proofs in the future. So we have a problem here where we're given a trapezoid. Well, not even a trapezoid, I'm sorry. We are given a quadrilateral. And it's quadrilateral A, B, C, D with K, L, F, and E, the midpoints of the sides in order. So K would be the midpoint of this side, L the midpoint of that, F and E the midpoints of those respective sides. We're going to try to prove that EF equals KL. So we're going to eventually draw some auxiliary lines that EF, and that's not even EF, EF is equal to KL, and that EF is parallel to KL. And then we're going to try to prove that that quadrilateral is a parallelogram. Just from any random quadrilateral, we're going to try to see if we can prove that. And so here we go. Let's try to prove this couple of statements and see what happens. So we already wrote down the given, exactly what we were told. And so let's say number 2, we're going to draw those auxiliary lines. Draw EF, KL, and we're also going to draw a diagonal, draw AC. And so I'm going to draw these lines here. I'm just going to eyeball the midpoints here. May or may not be perfect, but we're going to just do our best here. That's a little too curved there. Okay, the better that you draw your auxiliary lines, the more accurate your eyes will be able to see what you're trying to prove. And I already messed up here. I don't need to draw all those lines. Just need to draw EF and KL, and then I'm going to make the diagonal a dotted line just so it's not a whole lot of lines in my face. I probably should have drawn the other auxiliary lines dotted, but I wanted those to be solid so my eyes can see exactly what I need to see. Okay, since we were told that E, F, L, and K are midpoints, that means it's dividing all the sides in equal halves. So this side would equal this side of the line because this is the midpoint of this entire line, which means it's cut into 2 equal parts. And that would be true about all the other lines. We can't necessarily say that this line segment is equal to this line segment. All we know is that this was divided into 2 equal sides. So I'm going to say that is equal to this. That part of the line is equal to its other part, and so on and so forth. So lots of lines here. So now that we know we've got equal line segments, we're going to keep on moving ahead. And we should probably state why we can draw auxiliary lines. We are given 2 points, and 2 points determine a straight line. All right, number 3. This next statement, we're going to use our Theorem 25 that we've talked about previously to prove this next step. If we were to cover up half of this quadrilateral, and I'm going to try to just cover it up as much as possible, and we are given this triangle right here. I'm going to keep my pointer on so you can keep looking at it. We learned about a line in a triangle that connects the 2 midpoints. So hopefully now you can see it. If we just focus on this triangle right here, we have a line in that triangle joining the 2 midpoints. We have learned that a line in a triangle that joins the 2 midpoints, that it is parallel to the third side, and it equals 1/2 of that third side as well. And so we can pretty much state two things in one step because of the one theorem that states both of those things. And so I can say that KL is parallel to AC. I could also say that KL equals 1/2 of AC. I'm going to do the same thing with the other triangle that we have here as well. We know that this connects the two midpoints of two sides of that triangle. And since it does that, it is parallel also to AC, and it is equal to 1/2 of AC. So I can say that EF is also parallel to AC, and that EF equals 1/2 of AC. And this was theorem number 25, which simply stated in an abbreviated sense a line that joins the midpoints of two sides of a triangle is parallel to the third side and equals 1/2 the third side. All right, very truncated, abbreviated statement, but that is what Theorem 25 stated. So now that we have that EF and KL are both parallel to the same line and that they are both equal to 1/2 of the same line, we can make some pretty common sense statements. We can say that EF equals KL by substitution. Since they both equal the same thing, they both equal 1/2 of AC, then they would obviously equal each other. If 1/2 AC equals 1/2 AC, then KL equals EF. If they both equal the same thing, you could even think of it like this: KL, EF, both equal 1/2 AC, and it's kind of like a triangle where they would also equal each other. And so however you like to think of it, that is. You could also use another axiom that's known in geometry. Quantities that are equal to the same or equal quantities are equal to each other. Same idea there. Number 5. We can now say that EF is parallel to KL because they're both parallel to AC. We've already stated in number 3 that this and this are both parallel to AC. So if two lines are parallel to the same line, they're parallel to each other. Lines that are parallel to the same line are parallel to each other. And we've had many problems where we actually did prove that to be true. Number 6, we can now state that EFKL is a parallelogram. And if you wanted to actually make this a longer proof, I don't know who in their right mind wants to make things a longer proof, but we could have stated draw EK and FL to actually make that that quadrilateral that we're looking for. But in our own mind, we can see and observe that 4 points make a quadrilateral. So EFKL, or EKLF, however you want to say it, it is a parallelogram because we just stated that this line and that line are parallel to each other. And we also stated that they are equal to each other. And so we've learned a theorem that states, or maybe it wasn't a theorem, we proved it, I believe, that if two sides of a quadrilateral are both equal and parallel, that quadrilateral is a parallelogram. And so that would be our reason. If two sides of a quadrilateral are both equal and parallel, then that quadrilateral is a parallelogram. And so that's how you would prove something like that using theorems that we've used in the past. This isn't necessarily a theorem that we're learning. We just were given a couple things in a quadrilateral, and we proved that if lines join the midpoints of a quadrilateral, it forms a parallelogram. In the next video, we're going to see that if there's a certain type of quadrilateral on the outside and we join the midpoints of that specific type of quadrilateral, it forms a different kind of parallelogram, a specific type of parallelogram inside. And so stay tuned for the next video.